Hi, this is a demo of the Hackacam SDK. We're going to write a small program to capture some video and store them on a network drive, and we're going to try to do it all in 5 minutes. First, let me explain a little about the work environment. The left panel is where we're going to do all my source code editing. The bottom right is where I will do compilation, and I'm going to SSH to the camera on the top right panel to run the program. All three terminals share the same NFS location, so the data is consistent. In the directory, I already have a makefile, an empty source file, and a resource directory. The resource directory contains the binary run file to run the stretch DSP core, and all the required libraries and include files. Let's take a look at the makefile real quick. The highlighted variable defined where my cross-compile tools are located, and the compile line referenced the required include and library directories. Okay, so let's start by writing a hello world program. Nothing really special here, just a single line of printf. After we finish with the code, we can compile it in the compile window and run it on the camera. Since the camera is set up to access the same NFS location, the binary executable is instantly accessible. Okay, that was simple enough. Let's write code to capture some video. The first thing you have to do is include the sdvr sdk.h header file. After that, you can create a status variable to capture all the status return values. Then you have to call the sdvr_int function to initialize the SDK. The next step is to load the binary code to the stretch DSP core. To do this, we first define the binary run file path, then call the upgrade firmware function to load the code. Of course, we'll be checking for error messages of this function call. The next step is to initiate a connection to the stretch DSP core. To do that, we first have to create a board setting variable and set its video standard. After that, we can call the board connection function to initiate the connection. To get memset working, we have to include the string.h header file. After the connection is established, we'll then create a video encoding channel. The first step of that is to define the channel spec through the channel definition variable. Here we'll set it to an encoding channel and H.264 encoding. The board index and channel numbers are both set to 0, since we're only going to work with one channel here. Next, we'll configure the buffer settings. Here we're mostly going to use default values and only change the response buffer count and video buffer count. Now we're ready to create the actual channel handle using these two parameter variables, and we can do that by calling the createChannelEX function. Once the channel is created, we can go ahead and configure the H.264 encoder parameters. The first step in doing that is to get the default encoding parameters from the channel. This can be done using the getVideoEncoderChannelParams function. After that, we'll set the encoding resolution to the input resolution, which is 1080p, and set the bitrate to 6 megabits per second, and set the bitrate controller to constant bitrate controller. Once those parameters are set, we can call the setVideoEncoderChannelParams function to update the encoding parameters of the video channel. Now we're ready to enable the encoder. We can do that by calling the enableEncoder function with the enable flag. Once the encoder is enabled, the video will start streaming. So we'll insert a 5-second delay to capture some video, and then call the enableEncoder again with a disable flag to disable the encoder. After that, we'll do some cleanup. We'll do that by calling the channel destroy and the board disconnect function. Now you're going to wonder, where is our captured video going to go? The SDK captures all the incoming data via a single callback function. So we'll start by implementing this callback function and register it with the SDK. Next, we're going to open the output file handle so we can output some data to it. In the callback function, we're going to grab the frame pointer from the channel handle. From that frame pointer, we can then get the payload buffer pointer and the payload buffer size. We can then write the payload, which is the video stream data, to the output file. Sorry, I just noticed one bug. It looks like I called encoder enable a couple of times too many. Let me just fix that real quick. Now we're ready to run our app. So we'll just go to our SSH console and execute Hackacam hello world. And here we're going to have to wait for about 5 seconds to capture some video. Still waiting. Okay, great. Now it's done. So if we do ls, we can see that there is a output .h264 file, and that's our newly captured video bitstream. So now we can play back the video and see what we got. There you go. Okay, so this concludes our video tutorial. I hope you enjoyed it, and I will see you next time.